I'm the founder and CEO of Vertical Future, and today I will talk about vertical farming, one of a number of innovative approaches to agriculture, and how it is positioned to address various current and future challenges with our global food system. I'll also talk about my company's ideology and what we think needs to happen for the sector to evolve in a sustainable manner in order to meet such challenges. I'm Jamie Burrows, and this is my Oxford Talk. At no point in history has there been more of us on the planet, or on the whole, have we had such a high standard of living. Human existence has occurred in only the blink of an eye, yet within this time, the rate of transformation over the past centuries has been immense, and arguably the most important in the history of our species. Consider that in 1800, by a $1.90 per day standard, 81% of people worldwide were in poverty. 190 years later, poverty had fallen to 44%. In contrast, in the 32 years since 1990, poverty fell at 6 times the rate and is now less than 10%. Standard of living is, amongst other important factors, acutely linked to food. Today, the global food system gets taken for granted and is a pretty complex topic. As a result of globalization, technology, and many other factors, our planet has been incrementally reprogrammed, mostly over the past several centuries, in such a way where food supply and demand are connected on a global scale. This has been partly due to the availability and location of arable land, but more so due to the unchecked demands of more developed and wealthy countries for an ever-expanding diet, at both the benefit and expense of low-income countries. Whilst the standard of living for us has improved over the same period, the health of our planet has not. Food production contributes to 8.5% of global CO2 emissions, and change in land use, primarily through deforestation, contributes to 14.5%. Over 71% of land in the UK is used for farming, and in the US, 41% is used for growing solely feedstock, equating to 324 million hectares. Synonymous with the way our food system is structured, land use for farming isn't necessarily next to the areas of highest consumption, and the US provides us with a good example of this, with over $3 billion of lettuce lost every year through transportation from the west to east coast. Thinking more about our diets and personal choices, it's clear from the scientific literature that livestock farming is the single biggest contributor to biodiversity loss, and switching to a plant-based diet would free up approximately 3.1 billion hectares of land, equivalent to the size of Africa. The likelihood of the entire planet completely moving away from meat and fish is, on the other hand, probably very low. However, massive reductions in fish populations may make up people's minds for them, or mean that intensive fish farming will be the only source of fish supply in future years. For meat, such a transition may be less likely or take substantially longer, with only an estimated 22% of the global population currently vegetarian, the majority of which are out of necessity. The Green Revolution of the 1960s, driven by the adoption of new technologies in agriculture and focused breeding initiatives to produce higher yielding varieties, is a good example of how technology can be used for good to address systemic failures or inefficiencies. It has since been widely regarded as having a marked impact on the reduction in global poverty. We are now in a second green revolution, where once again improved agricultural technologies focus on meeting the needs of a growing population and planet in need of help. My work is part of an industry and movement by the name of vertical farming, which is defined as the growing of crops indoors using LED lighting, no soil typically, and under controlled conditions, negating the need for pesticides and other agrochemicals. Whilst not positioned for the most part to replace broadacre and greenhouse farming, vertical farming in comparison is considerably more productive, sometimes hundreds of times, and especially land and water use efficient. Its use is primarily in food production for human consumption. However, it has branched out in recent years to grow for the nutraceutical, pharma, perfume, and livestock feed industries, creating multi-use scenarios for vertical farms. Imagine a world where the soil is no longer usable, where major crop types have died out or can no longer be produced where we currently produce them. Insect populations have rapidly declined, and where hundreds of millions of people have had to migrate due to famine or rising sea levels. The vision is somewhat apocalyptic, but we already see the danger signs, and climate predictions going back decades continue to be proven and, in some cases, outpaced. Even a 2 or 3 degree increase in global temperature, whether it happens in 10 years or 50 years, will be catastrophic for our food system and planet more broadly. Procrastination is not an option. Vertical farming offers part of the solution for a planet that is going through massive change, but it also needs to be deployed in the right way, targeting rapid scale and price parity versus the wider market, for products that will in the future need to expand beyond herbs, leafy greens, fruits, targeting more staple crops such as grains, although the current unit economics and price levels are a long way from what is required. Like many nascent sectors, many vertical farming brands have also chosen to go down the premium route, almost always situated in developed countries and at a higher price point to the end consumer, doing little to address problems at the bottom. These models return value in many ways, but are not the long-term solution to global food production, nor a contributor in the context of fair pricing and equity of access for low-income families. To achieve the next step of evolution in vertical farming on a global scale, several questions need to be answered. First, when at a sufficient scale, how can these premium models that focus on developed countries become more price competitive and also move into more staple product groups, which are even more price competitive? On the other side of the coin, how can vertical farming evolve to meet the more stringent unit economics of developing countries, such as Kenya, India, and Vietnam? If climate change continues its current trajectory, there will naturally be a shift in where food can be produced, so the sector must act to solve issues in these geographies or act as a local substitute. Secondly, how can the sector build upon an already solid set of value propositions by addressing energy concerns and also moving towards a net zero? Given the rising cost of energy in the UK and other countries, versus the comparative long-standing concerns over the energy use of vertical farms, this is perhaps the most relevant question of all. We've spent the last 7 years building a company, team, and business model that aligns with a better form of conscious capitalism and globalization, aligning with the future needs of the sector. We design our own technologies, build farms for different customers, and sometimes operate them too. My wife and I embarked on this journey in 2016, and the team is now made up of over 70 staff, from software engineering through to plant R&D and engineering. Our drive, and that of our colleagues, is based purely on leaving the planet in a better condition than we found it, creating the best possible future for our children, who will hopefully all outlive the end of the century, but be there to see a sustainable future too. The vertical future model is built on 3 cornerstone principles that seek to address the questions I've posed. The first principle is fair pricing, both in vertical farming infrastructure and the price of the end product grown in our vertical farms. This starts with only delivering on projects that make economic sense, being honest with customers about the limitations of vertical farming, and knowledge transfer from first contact and into the future. The second principle is integration with green energy infrastructure. This is not feasible for every project, especially in urban areas, but as the sector evolves, it's clear that the bulk of vertical farming activity will take place in rural areas, where there is more space and fewer planning restrictions for on-site green energy infrastructure. Our vertical farming system is particularly energy efficient, but by integrating with on-site green energy production that can also be stored, we're able to better align with the green revolution. This is further supplemented by our evolving growth algorithms that seek to produce more plant biomass and maintain quality standards, often by using less energy due to the selection of appropriate light wavelengths that target specific responses in crop physiology. The final principle is returning long-term value beyond simply infrastructure and know-how. The future of agriculture, not only in vertical farming, rests on the data and scientific advancements we make, such as crop algorithms, that will materialize in coming years. When carrying out international projects, this also means a streamlining of the supply chain using local labor, manufacturing, and knowledge exchange. We're all living through an important time in history that is both fragile and, at the same time, exciting. And as a much better form of capitalism takes place, where greater social value and positive externalities are both constants in the future of our food system, we're hopeful that our sector will be one of the key points of difference. This will require a concerted effort to work with different actors, including investors, retailers, supply chain companies, and end consumers. If we do this right, our work will just be the tip of the iceberg as we go even further to build a better, more equitable global food system for all.